What's up guys, and welcome to this video. This is the 2018 IEP November exam. I've done some of this paper, but right now I want to go over question 6. Okay, and question 6 has to do with graphs. Okay, so we have been given a function f of x is equal to 2x squared minus 3x minus 2 over x minus 4. Okay, and question 6.1 says determine the intercepts with both axes. Okay, so 6.1. Okay, so the easiest, so let's get the y-intercept first. So to get the y-intercept, we let x equal 0. So what we have is f of 0 is going to be equal to, so wherever we see x, we put in a 0. So that's 2 times 0 squared minus 3 times 0 minus 2 all over 0 minus 4. Okay, and we get a value of, all of those are 0, so we get minus 2 over minus 4, so that is a half. Okay, so that means our y-intercept, the coordinates of our y-intercept are going to be x is equal to 0 and y is equal to a half. Okay, so the next thing we have to do is get our x-intercept. Okay, and we do that by setting y equal to 0. So to get the y-intercept, we set x equals 0, and to get the x-intercept, we set y is equal to 0. So let y equal 0. So we have 0 is now equal to 2x squared minus 3x. So 2x squared minus 3x minus 2 all over x minus 4. Okay, so we don't have to worry about the denominator, so we just have to worry about the numerator, which is 2x squared minus 3x minus 2 is equal to 0. So now we need to factorize this. We're going to have 2x. Then we're going to have x is equal to 0. Okay, so I know I am going to need a minus, so let's say minus 2, and we're going to need a plus 1. So does that work out? The outside, so this times this gives us 2x squared, this times this gives us minus 2, then we have positive x with those two, and minus 4x, so minus 3x. Okay, so that's factorized correctly. So now we can just solve for x. So we can say that x is equal to minus a half, and x is equal to 2. So our x-intercepts, are going to be minus a half and 0, and 2 and 0. Okay, and that is the answer to 6.1. And we get ourselves 6 marks for that. Okay, so the next question says determine the equation of any asymptotes. Okay, so the easiest one to figure out is our vertical asymptote. So to figure out the vertical asymptote, we set the denominator is equal to 0. So vertical asymptote, we set the denominator is equal to 0, so we can basically, to get it, we need to say x minus 4 is equal to 0, so x is equal to 4 would be our asymptote. Okay, then there's also an oblique asymptote. Okay, and the reason why we have this oblique asymptote, because the highest power of the numerator is greater than the highest power in the denominator for the x. Okay, so that's how we find out whether we have a oblique asymptote. And in this case, we have x squared at the top. We have, let's do it in a different color. We have x squared at the top, and we've only got x at the bottom. So there is going to be a oblique asymptote. Okay, so the easiest way I find is to just do long division, but otherwise you can do this by inspection as well. For this particular question, I am going to do it by long division. Okay, so the process for long division is what we have 2x squared minus 3x minus 2, and then we're going to divide it by the denominator, which is x minus 4. Okay, then what we do is we want to figure out what we need. What do we need to multiply? What do we need to multiply to this equation to get 2x squared out of it? Okay, so we need to multiply 2x. So 2x comes at the bottom, then we multiply this with that. Okay, so then we have 2x squared minus 8x. Okay, and then we subtract the top from the bottom, so we subtract it. Okay, so then what we're left with is 2x squared minus 2x squared equals 0, minus 3x minus 8x becomes plus 8x, which is equal to plus 5x, and then we bring that minus 2 down. Okay, now what do I need to, I'm going to take that away, what do I need to multiply here to get 5x? Okay, so I need to multiply by positive 5. So then we have positive 5x minus 20. Okay, and again we minus this, so we get 0, and then we have minus 2 minus minus 20, which is positive 18. Okay, and then our oblique asymptote is whatever is at the top. Okay, we can't go any further because there are no more x's. Okay, there's no more x's being pulled down over here, for example. If there was an x, we could have gone further, but there isn't. So this is where we're left off with, and we care about what is at the top. So our oblique asymptote, the answer to our oblique asymptote is going to be y is equal to 2x plus 5. Okay, so like I said, you could have done this by inspection as well. So the process to do it by inspection would have been to do the following. So you say you have x minus 4. Okay, now you say you have the numerator, which is 2x squared minus 3x minus 2 is equal to, and it has to go is equal to the numerator, sorry, the denominator, which is x minus 4, and then what do I need to multiply x minus 4 by to get my to get the equation to look correct? So I need obviously a 2x. Okay, if I have a 2x, then I'm left with 2x squared, which is what I want, and then this is going to bring about a minus 8x. Okay, so I need to get a minus 3. Yeah, so I need minus 3x. So something needs to happen. So I need to add plus a positive 5x. Okay, so I need to get in a positive 5x somehow when I multiply with that x right here. So I can just add plus 5. Okay, so if, let's say this was 5x, then I would only need to add plus x. But in this case, what we have is x, so I need to multiply it by 5. Okay, and there's going to be some remainder left over. Okay, but I don't care about the remainder like I didn't care about it here. So my asymptote is this equation right here, y is equal to that. But like I said, to me, it's just much easier to use a long division. Okay, and with that we get 8 marks. Okay, question 6.3. Okay, so question 6.3 says determine the coordinates of any stationary points. Okay, so to determine the stationary points, we need the derivative, and we set the derivatives to 0. So we start off with our expression, which is f of x is equal to 2x squared minus 3x minus 2 all over x minus 4. Okay, and what is my derivative? F dash of x. Okay, if you look at your formula sheet, then it gives you it in terms of g of x and f of x, I think. But what I'm going to do is I'm going to use some simple English. So I'm going to say that the derivative, when we have this division, a numerator and denominator, is equal to the derivative of the top. So it is the derivative of the top times the bottom minus the opposite of that, which is just the top times the derivative of the bottom. Okay, this thing here, this dash right here, just means derivative, all over the bottom squared. Okay, so that's how I would explain it in simple English. Okay, obviously in the exam, don't write this, write it in terms of f of x and g of x. But this is in simple English, this is how you'd go about this. Okay, so let's go ahead and go. Let's just leave that in actually. Okay, so what is the derivative of the top? That is equal to 4x minus 3, and then we leave the bottom, which is x minus 4, minus the top, which is 2x squared minus 3x minus 2, times the derivative of the bottom, which is just 1. That is all over the bottom squared, which is x minus 4 squared. Okay, so that is my derivative. Okay, now I can remove all of this. Okay, so that is equal to my f dash of x, and I need to set this equal to 0. Okay, so once I've done that, I can basically just multiply everything out now. So what I get is 4x squared minus 16x minus 3x plus 12 minus 2x squared plus 3x plus 2 is equal to 0. Okay, if I simplify this, this becomes 2x squared. Okay, those x squareds are gone. This cancels with that, so it's minus 16x and plus 14 is equal to 0. So I know that I'm going to need a 2. Okay, so I can actually make my life a bit more easier by just dividing everything by 2. So I'm left with x squared minus 8x plus 7 is equal to 0, which makes my life a lot easier. So I'm left with x minus 7, x minus 1 is equal to 0. Okay, so you guys should be able to factorize that very easily. So therefore, x is equal to 1 and x is equal to 7. So now I need to find the y coordinates. So what I do is I plug in x is equal to 1 into my original equation. So f of 1 is equal to 1 when you plug 1 in. So basically you're going to have 2 minus 3 minus 2 over 1 minus 4. So that is going to equal, those cancel, minus 3 over minus 3, which is equal to 1. Okay, so that's how you do it for that. And then f of 7 is equal to 25. Okay, therefore, okay, let me give myself some space before I continue. Okay, so therefore, the stationary points are 1 and 1, and 7 and 25 are these stationary points. Okay, so not too difficult, and we get ourselves 8 more marks. To question 6.4, basically the question says, use the fact that the double derivative f double dash of x is equal to 36 over x minus 4 cubed to determine the nature of the stationary points that you found before. Okay, so we're going to start off 6.4 by stating f double dash of x is equal to 64 over x minus 4 all cubed. Okay, and then what we're going to do is we're going to plug our values of our stationary point in, the x coordinates of our stationary point. So for example, if we plug in f double dash of 1, okay, and we just care about the sign, so we don't actually have to plug in a value, but we get our top is always positive. Okay, so this is for 1. So let's say this is f of x, and then this is f double dash of x. Okay, so what we have is the top is going to be a positive because it's always 64, and the bottom is going to be 1 minus 4, which is minus 3 cubed, which is a negative. Okay, so a positive over a negative is equal to a negative. Okay, if we move on to x is equal to 7, we have a positive at the top, and at the bottom we have 7 minus 4, which is a positive, cubed is a positive. So we have a positive. So what that means is f of 1, or f double dash of 1, is less than equal to, or less than 0. Therefore, 1 and 1 is a local maximum. Remember, it's the opposite. If it comes out as negative, it is a local maximum. And f double dash of 7 is greater than 0. Therefore, 0.725 is a local minimum. Okay, so yeah, that's that question done. So thanks for watching, guys. I hope you found it useful, and yeah, thanks.